Good morning, everybody, and welcome once again to the JKMRC Friday Seminar Series. On behalf of the University of Queensland and the Sustainable Minerals Institute, we would like to acknowledge the traditional owners and custodians of the land on which we meet today. We pay our respect to their ancestors and their descendants who continue cultural and spiritual connections with country, and we recognize their valuable contributions to Australian and global society. Today it's my great pleasure to welcome Luke Stannard. Luke is a minerals processing engineer with over 20 years experience and has driven gold and base metal operations across Australia, Asia Pacific, Africa, and South America. Specializing in efficiency, performance optimization, and asset integration, he delivers value in complex mining settings. As process manager at Resolve Mining Solutions, Luke leads Australian and global business development, building on senior roles at MMG Limited, where he enhanced operations, integrated assets, and boosted productivity. A board member of the Australian Saudi Business Council, he fosters trade between Australia and Saudi Arabia while leading projects development in Saudi Arabia and the north of Africa, integrating mining services for economic and environmental gains. Today, his talk is going to be about toll treatment, plant planning, and design considerations. Please join me to welcome Luke.
Thanks. So have done a little bit of the toll treatment and working in a regional context and trying to fit ore through a particular plant. Things from reconfiguration of plants, upgrade, debottlenecking. So from a operations point of view, feel like I've done most of the usual things in flotation and grinding. And again, appreciate the opportunity to come and talk here today. A bit of family history is that there was briefly a metallurgist in the family before ended up with an eye injury, but later went on to grow the music department at the University of Queensland. So it's held in high regard, the university here, and I really appreciate an opportunity to give back myself today. So on the Tennant Creek area where we're working at the moment, there is basically the one group at the moment, Pan-African Resources. They recently acquired the Tennant Creek mining group, and they have an agreement with Emerson Resources, and they have commissioned a plant this year that will treat a lot of the gold deposits of that region. Outside of those gold deposits, there's about 40 million tonnes of base metal resources within a 150-kilometre radius. And the genesis of this project, there's a gentleman who owns the Barclay Industrial Hub, who's sort of situated right in the middle of that area. So this site was originally an abattoir. It's been leased out to industrial clients over the years, rehabilitated and upgraded to be an industrial site. The vision for the site is that it will become a circular economy focused industrial hub that draws on the mineral wealth of the Tennant Creek region. And so right now, there's 3 of us working there. There's a group, Hydrera, who treat fracking water from the region. There's Circular Ecosystems, who's I guess sitting at the top layer, making sure generate value between the groups that work at the site. So the vision for that site is aligning with the Northern Territory government's economic strategies, and it's not particularly unusual. It's the usual create jobs where we can and leverage infrastructure that has been installed over the years. From a mining sense, in that region, what ended up becoming part of Newmont or Normandy was Pecco Mines, and they had a large area across that Tennant Creek region, uncovered a lot of copper, gold, and bismuth resources, and produced a significant amount of copper and gold over the years. Ran for I think, near on 40 years, and since that time, those assets have been all split up and sold off, and there's still some tailings that have been acquired through various groups and partially retreated, and I guess sort of remain as like a legacy item to deal with in time. So there's a few historic photos of the little mill that they had there at Pecco, which is sort of close to the Tennant Creek area. Well, the town of Tennant Creek is about 5 kilometres out. I think they had noted issues with some of the different copper minerals, recovering them. It was a flotation plant largely, so you had a bit of trouble with the oxide materials. And they also ran a bismuth smelter there for a period. They were able to separate a bismuth product out, which would have been great to see, because obviously there's probably a very low chance of there being another bismuth smelter in the country anytime soon. So, I guess there's a lot of learnings from the Pecco days from a technical point of view. So there's a lot of papers with grinding information and flotation information But the layer that needs to be considered nowadays is how to bring it all back together, where it once was a reasonably sized organisation working together to maximise the value for the one entity. Now we've got fragmented ownership, and all these groups are in different states, some with access to more capital than others. I guess the region now serviced with the gas pipeline, so there's a little bit of benefit there, that there's better power access. Otherwise, what is unlocked by this fragmented ownership is that it doesn't need to just be copper or gold to shove into the plants, the assets that they did have. There are groups that are open to other commodities. So there's been discoveries of rare earths and other critical minerals in the area. So designing anew you can bring in some other considerations. So I guess going into the offer that was made to stand up a toll treatment plant here at this site, we started to think about how to pull this together, and the framework that we've worked through. I guess there's a few questions here that we were asking ourselves. I think that some of the important things that we're mindful of is, there's been basically a generation since it was last operated. So what new learnings can we bring in? What new technologies can we leverage now? And importantly, if we can do this now, how do we replicate this so that we can take this elsewhere? That has sort of led to a framework under which we move forward through into design. The intent is to, I guess, have something that it would be classed as medium-sized, and should service most of, I guess, the known resources at this time. That's the only way we can really approach it. I guess one of the items that we want to try and achieve is to make sure that we have like modular design factored in, is that there's particular areas that might benefit from being able to move parts or the whole plant to a site for a short period of time or campaign period, and then come back. And obviously, because of the fragmented relationship, we need to build something that can service as many as possible. Groups that are maybe working in a similar space in the market at the moment, you have Coda Minerals in South Australia, who probably is more set up like Peco, where they have ownership of the sites, and their intent is to have one facility that can treat that material. ANAX is probably more similar to what we're doing, where there's a multitude of different deposit types. They have a site that has an old SX plant, so they have their intent is to build on a flotation plant and then have the benefit of being able to treat oxide sulfide material. So things that we're working through after, I guess, considering what is happening in the market, is looking for opportunities to bring in ore sorting, and also modern comminution flotation technologies. We'd be focused on getting the plant and establishing that before trying to, drive through ore ownership and, prioritizing that. The main thing is setting up a facility that unlocks value in the region. I guess, we're looking for opportunities to try to, use this more modern technology that can reduce capital spend and certainly OPEX, so that it looks competitive to use this as a toll treatment facility rather than groups having to look to set up their own facility. Other items that will probably come up in the next stages is items to make sure that the plant just runs all the time when it's needed. So having good asset management strategies and what are the sustaining operator principles under which you operate around training and development and longevity of operation. So the learnings that have come out from the groups in the region on the last slide, Coda, they started off with a plant design where they were going to make a separate copper and cobalt product, and they've ended up moving to a whole ore leach plant where they just make a copper product with which will have cobalt credits, and then they work in time after the capital repayment to stand up a separate cobalt stream. So I guess that learning is I guess keep it as simple as possible just to get it started, and then for the ANEX guys, they unlocked a lot of opportunity through ore sorting to be able to take a wider range of feed, sort sulfide material, and then separate out also oxide material so that they can either keep a flotation plant running or a flotation plant and their SX plant at the same time, depending on ore source. So, we've looking at the resources in our area with Pan-African Resources already in the area. They've got a gold plant. They can treat gold ores, but we're going to look at flotation opportunities, the range in the area listed there. But I think the reality is that the more significant projects are in copper, lead and zinc. So it's pretty much restarting what's been done there. So across the region, you've got resources from as small as like 200,000 tons up to 22 million tons. And I guess we were thinking that we need to be somewhere between that 300,000 and 850,000 tons per annum, and probably towards that higher end, as some of the groups have updated their resources lately. And because there is quite a big range on those numbers, we need to be thinking about flexibility. What equipment we choose needs to be flexible for, being partially filled in one part of the plant and full capacity at other parts. So that remains a driver. And at this point, I've reflected on some work that I've done previously for a client who had a tails treatment plant. They were treating tails material, producing a lead and a zinc concentrate, with intent to then retreat the material again and recover pyrite material. And there was a lot of rehandling there, but that was driven by a desire to not spend any capital or spend minimal capital to maintain existing plant, and they had limited capacity to move material on their transport corridor. So to recover all the minerals at once meant that they'd end up with a bottleneck. So they were treating and retreating. We were working with them to try to find a way to spend as little capital as possible and keep this plant going for, you know, another 10, 15 years to get through this recycling of material. They would be taking all the, you know, acid generating tails by removing the pyrite, leaving tails that could be capped safely. And they were also finding opportunities to perhaps, you know, restart little parts of the mine and put in fresh material as well. So the work that we did there, what we found from that is the easiest thing to do was replacing their aging flotation plant with just a handful of cells with both you know, Jamison cells or Woodgrove cells looking like they could be, you know, a minimal spend and replace solution where they would go from like 80 odd cells in the plant down to about 6. And by choosing the right size cells, we could configure for different feeds. And what unlocked this was the fact that it was already a large, complicated circuit that had lots of conditioning cells, transfer pumps and transfer pump options. So we could utilize them and just replace the cells only to yeah, basically keep that operation going. So that has driven the thinking on the flotation end. On the comminution side, this material in the region, even with publicly available information on the ores, looks very similar to days gone by. The material was ground to 75 microns. Then they would have, you know, rougher scavenging, some regrind, and that would be down to about 38 micron, and then produce, you know, about a 25-26% copper concentrate. So there's certainly no ore sorting information, nothing of relevance. That's work to be done. You know, I guess from a modern lens, this sort of plant, you might look at, you know, a 2-stage crush sag ball or a 3-stage crush with ball mill to do the same sort of thing. You know, would you have 2-stage crush, a HPGR and a towel mill? That sort of looks challenging on the hardness numbers, but still for consideration. You know, can we reduce grinding requirements through putting in you know, hydrofloat? You know, that's a consideration that we've leaned towards. Again, done some work on the Cadia hydrofloat installation and seen what that can unlock there. So that's driven a lot of plant design thinking. And I guess through some of the iterations on that, we've sort of looked considerably at the vertical roller mills, you know, particularly where we see opportunities for water reductions and power efficiency gains. So at the moment, tending towards that, and have built our scoping study around inclusion of vertical roller mill. So what I understand now is that there's been a bit of work in this space here. So I'll just sort of touch on these pretty quickly. So I guess more recently, Oz Minerals looked at inclusion of the vertical roller mills for the West Musgrave project, and that was seen as a way to basically do all your comminution during the day using renewable energy generated, and then they would, float 24/7 downstream, and they'd have a like a fine ore bin in between. In the VRM space, from a manufacturer point of view, you've got Lersch, who are looking at the vertical roller mill with hydrofloat and what can be unlocked there. There's Gebrüder Pfeiffer, also another German group, who are looking at good combinations of ore sorting and vertical roller mills. So there's a bit of work going on in this space that I guess we've relied on for our plant design. And for those who haven't seen these, you've got the feed coming in through that top chamber down onto the grinding plate down here, and then you're forcing in gas here to do your classification, pushing a product out once it is fine enough. The strengths is that for these machines, what they offer is an ability to get a large size reduction ratio in a single unit. Certainly their work shows significant power and OPEX reductions through less grinding media. They also see upside on flotation impact by not having so much iron put into the system. The biggest drawback being the capital to install these. In other applications, I think Dean David, who's spoken here, not about this, but their work with Grange Resources, they feel like the vertical roller mill has unlocked that project. That was a project that had power and water constraints, and with what test work had offered for that, they think that project can move ahead. So, as I mentioned before, in the past on that lead zinc recycle plant, what the learnings from that is that the use of the basic stuff of conditioning tanks and transfer pumps, and adding flexibility with those, they're low capital items, and that can enable you to use less flotation equipment, and certainly with some of the more modern cells, and we're looking to try and replicate that work again, reduce the amount of cells that you use, but build optionality. Fortunately, there looks to be a sort of a long lead of copper ores, so it should be a pretty basic circuit. We might need to put on a few cells for bismuth concentrates from some materials. But then in time, if the lead zinc ores of the region come on, then there's another couple of cells that might be built in. Again, we have sort of built the circuit around there being the hydrofloat in there to reduce the equipment size that we need downstream of that. That looks like it drops out both the number of cells required and the size of capital spend downstream. Certainly in the modest cases and on the more aggressive ones, but again, we need to test to prove that up. Again, this is obviously for those who don't have much knowledge of the hydrofloat. Flotation cell that focuses on the coarser particles, and what they offer is high mass rejection. At that coarse size, they can recover a lot of low liberation material. These are being typically used at the moment as scavengers on the back of flotation circuits to recover coarse composite material, and is unlocking upside on throughput on plants. And so far there's only the one example of it being used in a grinding circuit to reject coarse barren material early. And some of the drawbacks for that at the moment is that has a lot of has a requirement to separate material before it. So it's not just a float cell. It comes with requirement for maybe cycloning, or they use the cross flow separators with those. Some of the successes they've had. It's one of the earlier installations of the HydroFloat at a phosphate operation in the US, and here they had aging plant, wanted to upgrade. The HydroFloats were brought in because there was a large amount of material in the coarse fraction that had low recovery. What the HydroFloat unlocked for this mosaic operation was an ability to recover the coarse phosphate particles without more grinding. And so they had significant upgrade in throughput in that plant through the inclusion of the HydroFloat cells. And with an upside that they dropped out a lot of collector use at the same time. So they pretty good OpEx reduction. So we've I guess looked at the different equipment across what it can do, different size ranges, and taken the information that's available on these ore types and gone through a couple of iterations on plant design, and what has dropped out from that is pretty convenient in terms of having a simple circuit. Some of the things that are unlocking that are the requirements in between preparing feed for a HydroFloat and then what you can do to take that material down to liberation size, which is that requirement around 38 micron. That difference in particle size is something that can be handled in a single step by a stirred mill. So the largest simplification we see is basically having a HydroFloat recover a material that's ground in one stage through to liberation size to then have a very simple set of cleaning cells thereafter. So we've sort of triple checked so far with the information that we have available, and the circuit looks good on paper, and it is offers the benefits of much lower power consumption, and therefore becomes quite competitive on OpEx. So in terms of the circuit, like I said, pretty straightforward, where we crush and ore sort where we can to feed the roller mill. The roller mill for this type of material appears to be able to produce a product that is appropriate for a HydroFloat without the need for classification. And as I say, we expect a decent amount of material rejection from the HydroFloat before we do a single stage of grinding to basically final product size. And due to certainly the I guess respectable grades of the material in that area, we it looks like we can sort of get away with just the 2 stages of flotation to go to final concentrate. So far it looks like quite a simple circuit. For the units that are available, each of those have modular units. So, potentially we can pack it all up and move it around. From what I understand of the work that's been supported here is and certainly what has come out from Lurch is this configuration, needs further work to test that, and that's certainly focus of future work. Their plants that they have tested and written papers on it is around using the Lurch mills to separate your target product for separate flotation, and combining concentrates from your first 2 float stages before you regrind. So the difference between these two circuits is that your isomill is much smaller down here because you've rejected material. You've rejected material at this stage, but otherwise you don't end up changing these float cell sizes. And then the main difference is around your vertical roller mill configuration. These units that separate the 2 products have more installed equipment, so they come with a higher capex and a bit more opex as well. So we had the time to sort of run the numbers on the difference between the 2, and the size of the prize is worth pursuing at the moment through test work. The simplified circuit looks like there's a big impact on capex that we can make between the difference in the isomills and the VRM configuration. The drawback being that it will be slightly more expensive running the circuit with the larger isomill because it has higher power consumption and higher media use. But for the overall change in OPEX, that doesn't look like it will be enough to, justify moving into this 2-product vertical roller mill. This capital reduction means that you would take this OPEX. It also has the benefit of a simpler vertical roller mill, so it's easier to operate, and because you would be likely rejecting more coarse particles, you've got a tails material that's easier to handle overall. So I guess that's all the theory and thinking around our proposed circuit at the moment. Our next step is to really test this, and we'll go through all the usual motions of trade-off studies and piloting where we can to test this. We as much as we've lent one way with the design, ultimately at the end of the day, what's available and what capital restrictions we might have might drive changes in design, but where we have the opportunity to push the boundaries with that design, we'll keep pursuing that. And so that's about it.
Thank you, Luke. We've got plenty of time for questions. So, yep, Tom.
Thanks, Luke. That's really interesting. The other companies that are doing this, sort of setting up these toll treatment hubs, like Austral Resources, for example, as they already run one at SXEW, but they just bought the Rocklands plant. And I guess Coda's the same. have a deposit that they're planning to use as their primary feed source and then looking to other suppliers potentially to buy ore from. Do you have a sort of a primary deposit lined up to feed this plant? Or, you know, is it, and some kind of relationship inked out with an owner miner, or are you just casting your net wide to start with?
You're probably the latter, because I guess it's all been out. The industrial hub is looking for projects to build, so that's an easy step. If you've got a piece of land that you can use, it's got the benefit of it's freehold, so there's not processes to go through on native title and whatnot. So I guess that's its point of difference, is it can just go and do it. It's still a lot of the same environmental permitting, but it has its advantages from that space. Yeah, I guess we'll go and knock on the door once we've firmed it up. We need to now talk with these groups anyway. If we've staked our claim in this space, we'll be chasing material to start testing and prove it up.
And like ultimately, would Barclay be looking after sort of concentrate marketing and that kind of thing at the other end of it, or it's the model for the companies that are mining it, and you're just providing a service for them that they can then sell their product out of Port of Darwin or wherever?
That was bridged across later. Yeah, no worries. I guess it's does a company move that part of the service out from them, or do they bring it in house? And it's if you're getting a concentrate marketing person, it's whether we have it or they have it. One way or another, you pay for it. So yeah,
it's just about which parts of the risk profile you guys want to take on or want to outsource.
Yeah, exactly.
Thanks, Luke. Yeah, to the value proposition. Having worked in toll treatment space myself, I know there's several models to actually, for the toll treater to get remunerated. The resource owners jealously guard the value in their resource. What models have you been thinking about how you're going to get return on your investment and encourage the owners to use you?
Yeah, I guess the strategic position in this area would be that you can compete whether you are a fixed cost or fixed cost plus upside on performance share. There's a pretty good space due to the nature of the ownership in that area. It's all groups that have low market capitalization. If they want to build their own plant, they have to dilute their shares quite a lot. So from a today point of view, in a return per share view, you can compete with the rates that you charge. So I guess we haven't said that we would sit on a particular space, but there's quite a lot of room to be competitive, basically, as an option. So if we choose to do fixed fee or try and take some upside, we hadn't settled on either one. Just, I guess, identify that there's a big gap to compete in.
Yeah, and I guess the other thing is if you've got multiple users of a facility, some might be mining at 100,000 tonne a year rate and others mining at 500,000 tonne a year rate. And if you're looking to process at 800,000 tonne a year rate, how do you mix and match those? Are you going to be week on, week off campaigning of different ore types and having to change the plant every week, or tell one fella they got a stockpile for 2 years before bother sending it to you? Or lots of challenges ahead. I'll be interested in what's been your thought process so far.
Yeah, so that's a good bit as well of what Pecco was doing is they had, I think, 5 or 6 different mines, and depending on what year it was, they had 1 or 2 concentrators going. So that there's also already blending information about the material. With the materials down close to Tennant Creek being harder and the ones up to the north being softer, but generally, you know, they all had very similar liberation requirements, which is really, really nice, actually. Just being able, it looks like they've been able to have good blending flexibility. And so hopefully a lot of those copper ores are going to have the same upside now, where we can just put it all in and yeah, yeah, that's right. Subject to more testing, but again, at least historically, yeah, they blended those ores.
Thank you, Luke. Very interesting talk. Question, again, down to toll treatment. It's a very interesting geomet problem. How do you plan on adjusting your operating parameters based on the requirements of each individual ore body to give the best outcome?
Yeah, so I guess I've been thinking about the same thing as, you know, as I just mentioned, they were all blending ore in the past, and whatever it was, it just ground to 75 microns, and then it just floated, and they got 25 con. So that's great if that's going to work again. I guess with some of the equipment selection is can you still move easily from, say, if you have 75 micron grind requirement, maybe you can get away with 105 or 110.
Well, particularly since you move into the hydrofluid where the grind size is going to be in the 300 to 400. Is that really an easy move from 75 to 400 and expect to maintain the same processability?
Well, I guess it's a change in what you need from like the amount of liberation that you have at that size. So there is that information on what the liberation was like, you know, with what Hydrofloat has demonstrated, you know, looks like you can do it. The size, I guess, that we were expecting is around sort of 300 micron grind is the type of product from this material. So at least it's not getting shifted all the way up to some of the larger Hydrofloat sizes that they're trying at, like 600 or 800 micron. This should be like a modest relative step up in size. Unfortunately, it's too hard to speculate at the moment, but
I guess what I'm asking is that when one does the processability assessment of all these different ores, is that something that's going to be taken into account? Or are you simply going off pre-existing information that was determined on conventional flotation geomet assessment?
yeah, so I guess the biggest one is between like these 2 configurations.
Yeah.
If it is all really nice and it just works, well, that's great. But I think this circuit here, that configuration is going to lend more to, you know, like reasonable variability between size requirements. Because at least here, you know, you're just trying to reject whatever coarse barren material you can through the Hydrofloat. But if it needs to be 75 or 106 micron for your first stage flotation, I think that configuration is likely to be better for that.
So I guess what I'm asking is, do you have like a fixed system for assessment for how that's going to happen?
I guess it will be testing these configurations and having to...
At full scale?
Well, or piloting them in the facilities that are available.
I think you need to come and have a chat with us about that, is what I'm saying.
Well, that's what I found out. It's good that I came.
Yeah. Okay.
No worries. My name's Andrew, working comms. My question is about transport costs and availability. Is that going to be a bottleneck, or does that capacity already exist? And if it already exists, how do you tap into that?
So with the Pan-African guys moving into the region, they've maybe it's a bit of build it and they will come. There's a group, MMS, that have turned up supporting them with transport. Again, with the making some of these parts modular is their opportunity to say, take this part around to your sites and sort at site, and then just take product to the mill, and then reduce that reliance on transport as well.
Thank you.
No, it's a transport logistics related question too. I was just wondering, of the sort of network of deposits that are around there that you're looking as feed sources, are there any that are on the train line to the north that could potentially utilise that coming straight in? It's one of the, like Mount Isa train is on the train line, but the trains going back from Townsville to Mount Isa are basically empty. So if there's empty capacity sort of inbound to Tennant Creek, then there's a huge opportunity for cost saving there. Materials handling costs and all that sort of stuff notwithstanding.
Yeah, so part of some of the things that we've explored was what I think it's the return leg going north and south. There's a lot of spare capacity, so at least like bringing equipment in and finding opportunities to backload. We've seen that, but haven't looked further afield yet.
I mean, handling, like trucking ore around is problematic depending on how coarse. If you've crushed it before you put it on trucks, it's pretty damaging, just loading coarse freshly blasted ore into trucks and trying to truck it around. It damages the trucks, and it can move around and tip things over unexpectedly. But that's potentially issues.
I guess some of the questions that we've had overlap, and the ideal is as a toll treater, you provide a service, but if you can influence your customer, that's great, particularly when it comes to things like sticking big rocks on trucks. But that's where I guess being able to sort at a site, hopefully that can influence better outcomes.
Thank you very much for the presentation. It was very interesting. I mean, you mentioned that actually you were looking into wood-rich flotation cells as well, but it seems that you landed on Jameson, if I'm not wrong. Is that correct?
Yeah, and that's probably more on just I've already gone through some of the thinking and running the models on it. It's been a easy first way to do it.
Mainly because of the operational, or I mean, is it possible to tell what was the criteria to choose which one between the two?
Between the two at the time, I think what was easier on the last one was that the Jameson had more, use cases. I mean, it's pretty much done it all. It still gets its challenges still on the market, but it's at least done every single stage in a float circuit now. So and I've also run a Jameson in all of those configurations, all those different uses in a plant, so I'm comfortable having them in there.
Hi. Have you considered including a characterization lab in your whole setup, so your customers would have an idea of what sort of results they can expect before you process their ore?
Yeah, so that's in the scoping study and costed in, and I mean the hardest part is where it's located. So having a really good service there, I think might be challenging, but at least I think that's a good practice item that needs to be built in regardless. I think it'd be pretty disingenuous to say to someone, "Oh, we can we can get 95% recovery out of your ore, just hand it over. Like need to have a have a plant at least, or some sort of equipment in a lab that you can test and confirm. And I think that's obviously for where all these sites are and their isolation is, there's obvious benefits to being able to do that so close to source and turn results around quickly.
So I think this is.
Yeah, no, it's good because I have already pressed the equipment suppliers about what test rigs they have. Yeah.
We've got a question online, and the person is asking if there are any sites that use the VRM as a grinding tool.
So there's currently, I think they say there's like 2,000 of them installed around the world, but they tend to be in like slag treatment uses. There is one in Australia down in Port Kembla, which I'll get to see in the coming weeks. Yeah, so I think the Grange one, if that goes ahead, would be the first in Australia in a primary use.
All right, please join me again to thank Luke. Next week we have David Huston from Geoscience Australia talking to us. So please join us next week.